Good morning. So we are working on this. Remember, so we're using Kami. So remember, I just want to show you one of the features is the text box. So remember, you can do this. Okay. So I can write, how do you know when two figures are similar? Okay. So that's our essential question. Okay, and everybody also using the text box. Okay, so I'm going to be using the pen. Okay, so this one says two figures. Oh, yes, I can write on this better. Stuff. Okay, so two figures are similar if there is a similarity transformation. So remember what we worked on last semester. That maps one figure onto the other figure. Okay, so remember we talked about this earlier. That means that they're the same shape, but different sizes. So they've either been enlarged or reduced. Okay, also remember, so we also, all angles are congruent. All sides are proportional, meaning we can either multiply or divide by the scale factor to get the sides. So they're proportional. Okay, so what I mean by that, everybody, so remember scale factor, everybody, is new over old. Okay, so we have this one. So everybody, we're going to assume we're going left to right. So this is the old one. This is the new one. Okay, and we're going to do, so new over old. So I'm going to pick a side. So if I do 18 over 30, I can divide them by the greatest common factor, which is 6. So we get 3/5. Okay, and then we have 15 over 25. We can divide both of them by 5. So we get 3/5. And then we can also do 12 over 20. I can divide both of those by 4. They're even, so you could divide by 2 and then divide by 2 again, and we also get 3/5. So notice the scale factor for all of them is 3/5. Okay, now we want to list the congruent angles. So congruent S is congruent to angle Y. Congruent T, angle T, is congruent to angle Z. And then we have angle R is congruent to angle X. Okay, so if we're going to write a similarity statement, we just need to go the same way. So if we say T R S is similar to Z X Y, okay, that's doing the similarity statement. Statement of proportionality is talking about the sides, okay. So if I put ZY is proportional to TS, ZX is proportional to TR, XY is proportional to RS. Okay. So this one, everybody, we're going to do the same thing. So we're going to go, assuming we're going left to right. So this is the original one. This is the new one. Okay. So remember, scale factor is going to be equal to new. You can say over old or the original. So we're going to put, we can pick any two sides. Let's say that we pick QP. So PQ and JK. Nine over 6, we can divide both of those by 3. So it simplifies to 3/2, everybody. So yes, you always do want to simplify it. Okay, now let's list all the angles. So J is congruent to angle P. Angle K is congruent to angle Q. And angle L is congruent to angle R. Okay, and if we're going to write a similarity statement, so we could say that KJL is similar to QPR. Okay, and then if we have this, so it's QR over JK, PR over JL, PQ over JK. Okay, so all those sides are proportional. Okay, so this one we're going to find the missing length, everybody. So our first steps, everybody, so we're always going to find X and that corresponding side, okay? And then you're going to find a side without X. Okay, so any of the other sides work, and then we're going to cross multiply and divide to solve our proportion. Okay, so we're going to assume so that this is, we're going to go, that's the original, this is the new, okay? So I see X, the corresponding side is going to be 30. Okay, so I'm going to put new over old, so 30 over X is equal to, I'm going to pick 15 and actually, let's do the other side. Okay, so let's do 20 and 24, so MP and DF. Okay, so we're going to do 24 over 20. We're going to cross multiply. And we can cross multiply because there is a equal sign there. 30 times 20 is 600. Divide by 24. And everybody remember you can use desmos.com/scientific. Okay, and we get 25. Okay, so another example, everybody. Remember, we're going left to right. So you always want to draw the diagrams and label it. Okay, so we're going to have, so I find my X. So that's the side BC. So we're going to put RS over BC. So 4 over X. Okay, and then we're going to do, we can pick any side. We're going to pick the top side. So QR over AB, so 6 over 12. We're going to cross multiply and divide again. So we get 6X is equal to 48. Divide each side by 6. And we get X is equal to 8. And I just realized I need to move this over here. That one takes quite a bit of room. Okay. Okay, so let's look at this one, everybody. So this, you could do where you draw these triangles out because there's two triangles. So this one, we have, so this is the J, so -4 plus 4x, 27 and 36, okay? And then the larger one, we have 72. I'm going to use a different color. Okay, so 72, 64. Everybody see what I'm getting these? 74, 64, and 96. Okay, so we can do the same thing that we did before. So you can draw that out, or you don't have to. You could also use it in here. So we have the 4x. Okay, it's going to correspond to 64. We're going to assume that this is the old and this is the new. So we're going to put 64 over -4 plus 4x. And I can pick any other side. And I will do, I guess we can do the other one. We will do this one. So we're going to do 72 over 27. Okay, we're going to cross multiply. So with this, notice we are going to end up with 72. Remember, we have to do a parentheses around that, so we're going to have to do our distributive property. 64 times 27 is 1,728. Okay, then we're going to do our distributive property. So distributive property, hooray! Okay, so we multiply 72 times -4, we get -288. 72 times 4 is going to be positive 288. Okay, and then we're going to go ahead, add 228 to each side. Okay, so that's 0. So then we get 28x. So 288x is equal to 2016. Okay, we're going to go ahead and divide. Each side by 288, and we have x is equal to 7. Okay. Okay, so these ones, remember, we're going to go left to right. These have been transformed. Okay, so be careful with these ones. So this is the old, this is the new, this is the original, this is the new. Okay, so look for x. Careful on this one. Notice that this is the longer side. So SR over BC. Okay, so everybody, so notice, BC over SR is equal to DC over ST. Okay, because those sides correspond. Okay, so then these sides correspond. Okay, so DC and ST. You really can't tell. Okay, so let's go ahead and set it up. So it's going to be 60 over 11x minus 4 is equal to 50 over 70. Okay, remember we have to do the parentheses again, so we're going to multiply. So 60 times 70, I know that 6 times 7 is 42. So 42, add 2 zeros. Okay, and then this one, we're going to have to do our distributive property again. Hooray! Get to distribute. Love it. Just getting to multiply. Okay, so that's going to be 5, 0. Okay, I'm going to add 200 to each side. Remember what we do on one side, we got to do to the other side. Divide each side by 550. Remember, you can use decimals.com/scientific. Okay, everybody, so do these. X is equal to 8. Okay, and then for the next one, we can set that one up too. Okay, so again, be careful, look for the sides. Okay, notice that DE and CB are the longer sides. Okay, so it's going to be 30 over 11x plus 11 is equal to, and then on the other side, we're going to have EF over AB. Okay, so 21 over 77. Of course, we're going to cross multiply. Everybody use your tools when you're doing these. Okay, especially when we're getting like these really larger numbers. So we're going to have 21 times 11x plus 11 is equal to 2,310. Okay, I'm going to distribute. It's 231x plus 231x is equal to 23,200. I'm going to subtract the 231 from each side. Remember what we do into one side, we got to do the other side. So we get 2,079. And then we're going to take and divide that by the 231. And we get x is equal to 9. You got this, everybody. Okay, so